You think you're sitting still right now. You're not. At this exact second, you are hurtling through the cosmos at speeds so mind-bending that if you could see it from the outside, your jaw would drop. We're not talking about the Earth spinning. We're not even talking about orbiting the sun. We're talking about something so much bigger, so much faster, so much stranger that most people go their entire lives without ever knowing the full truth. So buckle up, because after this video, the way you see reality will never be the same. The illusion of stillness. Let's start with a simple thought experiment. Imagine you're on a smooth, cruising airplane at 35,000 feet. No turbulence. Constant speed. If you close your eyes, you can't feel any movement at all. Drop a ball, it falls straight down. Toss a snack to a friend, it flies in a perfect arc. Everything behaves as if you're sitting completely still on the ground. This isn't a trick. This is physics. Galileo described this phenomenon back in 1632. He called it the principle of relativity, the idea that there is no universal, absolute frame of reference for motion. Motion only makes sense relative to something else. So the real question becomes, relative to what is the Earth moving? And once you start pulling that thread, everything unravels in the most spectacular way. The orbit everyone knows. A and D gets wrong. Most of us were taught that Earth orbits the Sun. Simple, elegant, a near perfect circle. Except it's not a circle. Earth's orbit is an ellipse, an oval. Which means there are points in our yearly journey where we're closer to the Sun and points where we're farther away. The closest point, called perihelion, occurs around January 3rd. The farthest, aphelion, falls around July 4th. Yes, Earth is actually closer to the Sun in winter for the northern hemisphere than in summer. Mind blown? Good, we're just getting started. And here's something your school textbook almost certainly glossed over. The Sun doesn't stay still either. The giant gas planets Jupiter and Saturn are so massive that their gravity actually tugs on the Sun, causing it to wobble. The planets don't orbit a perfectly fixed Sun. They orbit the shared center of mass of the entire solar system, which is sometimes outside the surface of the Sun itself. The whole system is in constant gravitational negotiation. Over thousands and millions of years, these gravitational tug-of-wars called Milankovitch cycles slowly alter the shape of Earth's orbit, the tilt of its axis, which wobbles between about 22 and 24. 5 degrees every 41,000 years, and the timing of our seasons. Scientists believe these long, slow shifts are responsible for triggering ice ages. In fact, based purely on natural cycles, some researchers suggest a new ice age could be on the horizon, though our current impact on the atmosphere is overriding those natural rhythms in ways we're only beginning to understand. If this is already blowing your mind, hit that like button right now and subscribe. We're about to go several levels deeper, out past the solar system, into the galaxy itself. Don't go anywhere. The galaxy is alive, and we're riding through it. Here's where it gets truly epic. Our entire solar system, the Sun, Earth, every planet, every moon, every asteroid is moving through the Milky Way galaxy, not slowly drifting, screaming through it. The Sun orbits the center of the Milky Way at roughly 143 miles per second. To complete one full lap around the galactic center takes approximately 230 million years. That journey is called a cosmic year, or a galactic year. The last time the Sun was in this exact position in the galaxy, dinosaurs hadn't even appeared on Earth yet. The Milky Way itself is a massive spiral galaxy, stretching over 100,000 light years across. Our solar system sits in one of its spiral arms, about 25,000 light years from the galactic center. Unlike the solar system where the Sun dominates gravity and everything orbits it, the galaxy has no single dominant mass. Instead, everything pulls on everything else in an enormously complex gravitational web that includes not just stars and gas, but something we can't even see: dark matter. But the motion doesn't stop at a simple circular orbit. The sun's path through the galaxy is slightly elliptical, and it also bobs up and down through the galactic plane like a horse on a cosmic merry go-round, completing one full vertical oscillation roughly every 60 million years. Right now, we're several dozen light years above the middle of the galactic disk, still drifting upward. In a few million years, we'll peak at around 300 light years above center before gravity drags us back down. Here's the chilling part. Some astronomers believe this vertical bobbing is not just a quirk of orbital mechanics. The Shiva hypothesis suggests that every time our solar system dips through the denser, more radiation-heavy regions of the galactic disk, the increased bombardment of cosmic rays and gravitational disturbances could trigger mass extinction events on Earth. The timing aligns eerily well with several known extinction events in the fossil record. We may not just be riding through the galaxy, we may be at its mercy. The local group, AND, the Great Attractor, zoom out further. The Milky Way doesn't travel alone. It's part of a gravitational family called the Local Group, a collection of more than 54 galaxies, including our nearest large neighbor, the Andromeda Galaxy. And right now, the Milky Way and Andromeda are racing toward each other at several hundred miles per second. In about 4.5 billion years, they will collide and merge into an entirely new galaxy. The night sky, for whatever life exists then, will look completely unrecognizable. But even this cosmic drama is being pulled by something larger. The entire local group, all 54 plus galaxies, is being drawn toward a mysterious concentration of mass known as the Great Attractor. This region sits roughly 150 million light years away and exerts a gravitational pull so immense that it's hauling the local group through space at about 373 miles per second. We can't even see it directly because it sits behind the dense star fields of the Milky Way's own galactic plane, a cosmic mystery hiding in our own backyard. The universe itself is moving. And still, we're not done. The universe itself is expanding, not like a balloon inflating into an empty room. Space itself is stretching. Every galaxy is moving away from every other galaxy, and the rate of that expansion is actually accelerating. The laws of physics, as we currently understand them, cannot fully explain why. To get a true sense of Earth's total speed through the cosmos, scientists use the cosmic microwave background radiation, the faint afterglow of the Big Bang that fills the entire universe. By measuring tiny variations in this ancient light, researchers have calculated that our entire solar system is moving through the universe at roughly 229 miles per second relative to this cosmic backdrop. Every second. Right now. As you watch this. So let's do a full recap of what's actually happening to you at this moment. Earth is orbiting the Sun. The Sun is dragging our entire solar system through the Milky Way at 143 miles per second, tracing a corkscrew path that bobs above and below the galactic plane. Our galaxy is being pulled toward the Andromeda Galaxy. The entire local group is being sucked toward the Great Attractor at hundreds of miles per second. And the universe around us is expanding in every direction simultaneously. You are not sitting still. You are on an extraordinary high-speed journey through an almost incomprehensibly vast universe. And the fact that you can look up at the stars and begin to understand all of this, that might be the most remarkable thing in the cosmos. If this video changed the way you see the universe, share it with someone whose mind you want to blow. And subscribe, because we're just getting started on the biggest questions in existence.